So when I teach cities, I like to think of the reason that cities exist is because of the friction of space. And they've existed for thousands of years. People communicate with each other. People, workers and firms have to connect. People have to shop. They have to go to the marketplace, whatever period of history you're talking about. And all those activities have to cross distance. They have to go across space. And there's a sort of a premise in urban economics or a thought that if in fact you make it easier and easier and easier to get around across space, faster to travel, at the speed of light or whatever, you might really sort of short circuit cities. You might say, well, we don't really need cities. Everybody can live on a mountaintop somewhere and get to any other place and do anything they want. So the two really practical things that have sort of short-circuited the city model in the last couple decades are, first of all, e-commerce, which I'm not going to talk about today. And the second is work from home. So work from home, my take on work from home is that there are two central issues in it. One is it has a big effect on commuting, and commuting has a big effect on work on home. And the other is there's an endless debate about productivity, whether working from home increases worker productivity or decreases it. Depends a little bit on who you talk to. But I think both of these things are true and they actually connect with each other. And that is what this research is about. So just to show you some data here, this is a bunch of cities during COVID. And on the horizontal axis, there's the change in work from home share. 20 percentage points is a big number of people working from home who previously weren't. And on the horizontal axis, you have what happened to commuting costs, and they plummeted. It became much easier to travel around cities. So this link between work from home and commuting is quite clear. What we want to think about a little bit is the connection between work from home and productivity. But before I do that, let me sort of summarize what a lot of people have found in the COVID and post-COVID period about work from home. We know, of course, that work from home is concentrated in certain industries and occupations. Services, you can't work from home because you have to deliver the service. That's kind of like, by definition, an industry or sector of the economy where you can't work from home. We know from a lot of early studies that prior to COVID, there was this little trend in work from home. The government has identified it. Labor economists have found it was kind of sneaking in there. Every year, a little higher percentage of people were working from home. And then COVID hit. But there's definitely a sort of pre-COVID trend in working from home. We have a lot of case studies of productivity. The question as soon as COVID hit and people were forced to stay at home was, well, how much less productive are they working at home? And there's a lot of debate about that and a lot of contradictory studies. And I'm just going to say the jury's completely out on that. I believe there may be some productivity disadvantage, but it's hard to identify. Then there were lots of real estate studies, and they all showed flattening of house price gradients, that the premium people pay for central living as opposed to peripheral living really dropped. And it dropped in rents, it dropped in prices. Some papers showed and argued that overall housing demand increased. Of course, that's easy to understand. If you're working from home, you have to have a home to work from, right? So you need more space if you're going to spend, your whole working days at home. So that makes sense. There was a flattening also of commercial price gradients. And that's a lot harder to explain. Some people said, well, the CBDs are where all the occupations that are, according to the first point, all the occupations that you can use work from home for, that's where they're located. So there was more work from home in the CBD than in the periphery. And that lowered the rents firms were willing to pay in the CBD as opposed to the periphery. The rent thing is definitely there. Then there's this really interesting paper that I won't try and get into called bifurcation theory. And this says there's really two types of cities. And depending on where a city starts, it can either spiral off and have everybody work from home or I can spiral off and have everybody work in one big, huge downtown CBD. And the guy who wrote this paper, Esteban Rossi Hansberg, is a very good mathematician. It's a really good paper. Okay, so what are we going to do? Okay, we're gonna look at this issue, first of all, of productivity, output per worker. And we're going to build a little model which says it depends on two factors. The first is external firm agglomeration. So when firms are nearer to other firms, right? They share knowledge, they pool workers, they do all sorts of things that economists have argued since Alfred Marshall increase worker output. The second thing, which has come up now with work from home, is internal agglomeration. If everybody comes to work every day, then in theory, companies are able to operate a little more efficiently because their workers mentor each other. You get on-the-job training. Whereas if everybody's off working, on their own laptop at home, you don't get that kind of interaction between the workers within the firms. So, having all your workers at work in this model is going to have an advantage. The question is whether the advantage is worth it. So what the model winds up saying is worker attendance should be lower for those with longer commutes. This is just, simply when you have a long commute every day, less you're going on that commute because you're working 4 or 3 or 2 or 1 day a week. Every day less you're working saves you more money when you're commuting 40 miles than when you're commuting 4 miles. Okay? And we would expect that to be a common pattern in the data, at least if this theory is sort of correct. And then the other really interesting thing is that firms, we argue, have an incentive more than they used to move to the suburbs. Now, if they move to the suburbs, they're losing that first point. They're losing the proximity to other firms. They're going off on their own, so to speak. Okay, but on the other hand, as they get nearer to their workers, the workers are going to come to work more often. So you move to the suburbs, you lose what we think of as, agglomeration between firms, but as you get nearer to your workers, the workers say, oh, I'll go to work. It's just a 3-mile commute. It's not a 30-mile commute. Okay, so, though that's sort of the idea, we could draw a little diagram here of this and how it works in a Ricardian model. And I don't have a good pointer here. And then, you have firms in the middle, but the firms right at the center are most productive. The firms at that boundary M are least productive because they're further away from other firms. And then if you look at residents, they're out in the outer ring, okay? The residents who live way out at the border B and commute all the way into the center, they have the longest commute. And this model says they're going to work from home the most, or they're going to attend work the least. And then if you take some worker who lives just to the right of M and some firm that lives just to the left of M, all right, that pair of jobs and workers, they're going to go to work every day. All they have to do is walk around the corner, get in the car. Work might even be a relief from home because there's no real commute associated with it. So that's the way our kind of model thinks about things, okay? And what this model does is it makes a couple of empirical propositions. It says we don't have any data, we're not going to have any data on rents and prices, but we are going to have data that allows us to say how often are people coming to work? And how does that depend on where they live and where their work or their firm is located? Okay? And the hypothesis from the model, okay, is that the attendance rate, 5, 4, 3, 2, 1 day a week for workers is much lower when they live further from their workplace, regardless of where those two are. The second is the attendance rate is higher at firms who have moved outward more into the suburbs, closer to their workers. All right, and then the model also says there are these effects on rents and prices. the traditional rent gradient should flatten for both residences and for firms. So the question is really kind of, what are we going to do to see if this actually holds any water? I will say this is an MIT piece of research, so of course there's mathematical appendices, but we're not going to go through any of that, okay? That's just what comes out of this, okay, is these hypotheses. Okay, so the data that we're using is from the Castle Systems Company, which is the people that operate turnstiles in office buildings. And they monitor really very, very carefully how many workers come today each work, and they separate out whether, the worker goes out for lunch and comes back. They're just creating a variable, which is, what share of workers came to work today, and it's daily. And it starts in February 2020 and goes up. Our data goes up to the middle of 2023. And all this data looks kind of like this. On the horizontal axis, this is the log of the number of visits to each building. And the buildings with, log 7, that's a 1 million square foot building. And the little buildings down there, log 2 is a small building. And you can see there's kind of this common pattern that as COVID takes over in 2020, attendances, drop. That's a really big drop. They drop by 40, 50, 80%. And then they slowly come back. They have little waffles to them. Each line here is a building in San Francisco, and it's weekly attendance. We're not looking at it's another question, the Monday, Tuesday, Wednesday, Thursday, Friday hybrid model. We're just looking at average weekly attendances, okay? And that's sort of what the Castle data looks like, and they gave it to us, and they gave us some other details about where these office buildings are located, so we can actually kind of address these questions that we were looking at here. What explains why one office building has a different or lower or higher pattern of attendance? We tabulate these up. These are simply the averages for 11 metro areas. You can see them over there on the right. And this is, 30, 40, 50, 80 buildings per metro area. And here, every building has been benchmarked to its attendance rate before COVID. So it's what was the attendance rate in January of 2020? And then relative to that, did it drop to 50%, 40, 30? Did it come back? Whatever it is. You can see that across these cities, there's a very strong pattern. This is just a building tabulation. And so you can see attendance drops, Jesus, 90% almost, the first couple months of 2000. And then it claws itself back to about 70% a year and a half ago, okay? And it's pretty much stabilized since then. Now, another interesting thing we get with this, you can see the pattern across cities is pretty similar. Another thing we do with this data is we weight the tabulation. So instead of looking at the average building attendance rate, we look at the average worker attendance rate. So you take the number of workers in each building and you say, all right, this many workers attended. So it's like a weighted average of buildings. And there the drop is even more dramatic. So the drop in worker attendance goes 95%, and it comes back only to about 50%, which is kind of a benchmark that's around now in the data. The reason there are these differences between these two is because there is a very distinct pattern which larger buildings have lower attendance. You control for everything you can, and for some reason, buildings with big floor plates and tall buildings just have lower attendance, all else equal, than little buildings. So that gives rise to this. All right, so now what are we going to do with this data? We have these sort of, I've shown them by metro area, but we have a profile like this for each of 2,100 buildings in the United States across 115 metropolitan areas, okay? So what are we going to do with this? We first of all know the distance of every building in the Castle data set to its CBD. And this is the probability density function of distance of each building to the CBD of the metro area that the building is in, and it kind of looks reasonable. I mean, it's the mean's about 10 miles, the median's a little longer than the mean. That's what that data looks like. Now, the other thing we do, we want to look at the commute distance. Here we use this data that my research assistant and co-author really got for me, Sadi Saburi. And I should say this was done jointly with the Sensible Cities Lab, which is a bunch of data scientists that are one floor below us down at CRE. I couldn't have done this without, their help and without Sadi's help running and crunching all the numbers. But the loads data is basically IRS data. And it manages to know where you live, because you filed your tax return, and they have a way of estimating where you work. And they do that for like 100 million people in the United States. And I actually have you in my database. Of course, I don't have your name or where you are or anything about you, okay? But the loads data is just a treasure trove. And so we are able to, with the loads data, we're able to say, let's take the zip code that each building is in. Okay, sometimes buildings are their own zip code. I mean, it's a small area. And look at what the average commute is of all office workers who work in the zip code that the building is located in. And that's what this looks like. All right, there's your travel distance, the average travel distance for workers who are working in the neighborhood of where the building is located. And then we have to control for industry mix. So once we have the zip code of every building, we know the industry mix of zip codes. That's BLS data. And this is the proclivity, the propensity to work at home, 40%, 50%, 20%. The propensity to work from home according to the mix of industries and occupations that work in that zip code where the building is. Okay. Another thing we did with this data is we looked at the COVID rate, infection rate of COVID in the county. We maintained county records in the county that surrounds the building. And the line here is our average attendance rate across all the 2,100 buildings. And the shaded area, the shaded things are new COVID infection rates. And you can see the winters of 20 and the winters of the 21 all had, pop-ups in COVID, and they had drops in attendance. And by the time you get to 23, the winter of 22, 23, there's still a drop in attendance, but the data about COVID is getting sketchy because people are not reporting it. The vaccine is taken hold. So that's happening. All right, we stir this into a pot and we get something that's a little similar to a proportional hazard models. And what we're asking is, how do the variables we're concerned with, commute distance, the proclivity based on the industry mix, the distance to the CBD, how do they impact the entire pattern that looks like this? Is that pattern shifted up? And so you have a building that has a higher than average attendance. It still has this pattern, or is the building shifted down and it has a lower than average attendance? And we get all the results that we want, okay? Which is we have very significant coefficients on the industry mix variable with commuting distance, decreases attendance, increases work from home. Distance to the CBD increases attendance, decreases work from home. It fits perfectly. It exactly aligns with what our theory suggests it should. So rather than focus on the coefficients, we can think about what the meaning of the coefficients is. So if a building is 15 miles further from its CBD, its entire time path of attendance shifts 12 percentage points higher. That's quite a lot, okay? And then when a building has a worker commute, average worker estimated commute that is 15 miles longer, attendance shifts up by close to 8 percentage points. And then when there's a 15 percentage point greater likelihood of working from home based on the industry mix of the zip code, attendance, drops 9 percentage points. Work from home increases by 9 percentage points. We have a lot of things that we would like to do with this data. It's going to be an ongoing research project. We want to look at non-proportional shifts in the hazard function. We also want to examine hybrid work. We can take the daily work and say, what's the variance in days people are at work relative to the mean. We could study that. So that's on our agenda for future work. And then I think there's a couple of implications that we ought to think about in terms of how office markets operate. First of all, for tenants, there's this question of coordination. What workers do we want to come to work together? What days and in what locations? It's not that, research has to talk with marketing or vice versa, but what, the firm has to really think about what kinds of space it needs when certain groups of workers are going to come to work more often than not. And there are questions about building management. So every time I talk to somebody who manages or owns or operates office buildings, it's one question they ask me is they say, can the same space ever be shared between tenants? Firm A uses it Monday, Wednesday, and Friday, and firm B uses it Tuesday and Thursday. And I go, it's going to be difficult. But it is in some sense a little bit of a holy grail that owners and managers are thinking about when you have this problem. Here's another really interesting question that comes up, which is urban spatial structure. So when you mix, this is based on our model, when you mix land uses, you put workers closer to work and work closer to workers. Okay, and when you do that, okay, you're going to, in our model, raise the attendance rate. So that says, well, there's actually an advantage, okay, you increase internal productivity if you, for example, in Manhattan, you convert office buildings to apartments, because then all those workers are living right next door to their office buildings, and then that means they're going to come to work 5 days a week, and productivity is going to go up. And you get the same kind of argument when you think about putting residential use next to suburban office parks or malls in the suburbs. Those people have such a low, a small commute that they're going to go to work more often. And then in this model, that's going to raise productivity. But the trade-off is when you mix uses, you reduce external agglomeration. Rather than have all firms of one type here and all firms of another type over there, they're all mixed in with workers. And so you're going to lose external productivity if you mix land uses. This is a really kind of important long one question. It may be for certain types of firms, this reduction in external productivity is more important, so they should stay very concentrated.
Thank you.